Solving quadratic equations by graphing. So when we have to do that, we have to think about how many solutions the quadratic can have. So let's think for a moment and think back to the shape of a quadratic. We have to remember that a quadratic is a parabola, and what it will do, it can cross in two places, so it's possible to have two solutions. It can touch the x-axis, so it could have one solution, or it may not touch anything in the x-axis and it'll have no solution. So let's kind of go through what we should already know about quadratics and the way to graph them. So let's remember, we always have a plan. First, we have to make sure that it's in standard form, which is ax squared plus or minus bx plus or minus c. And you'll notice I say it's equal to 0, because once we start solving for a quadratic in one variable, we need to set that y to 0. Now we need to find the axis of symmetry, which is the same as the x-coordinate of the vertex. So we're going to find the vertex and plot on the graph, and then find another point and mirror it on the graph. And that other point that you can find, obviously, is the y-intercept. That's the easy thing to pick. And then we're going to draw the graph. Some other things to think about that we've talked about before is finding zeros of a quadratic function. We know that finding zeros of a quadratic function is the same as where the parabola crosses the x-axis, where y equals 0. How many solutions a quadratic has. If we remember that, and we were just talking about it a moment ago, looking at this diagram, we can see this is where y equals 0. This is where the parabola crosses the x-axis. So that kind of helps us in looking at these things. That will also tell us how many solutions a quadratic has. Now we need to remember that where the graph crosses the x-axis is also called the roots of the equation. Well, this is the same and also known as the solutions to the quadratic equation. So even though we're getting a lot of different vocabulary going on, we're basically looking for the same thing. So let's take a look and graph a few problems. First of all, 2x squared minus 8 equals 0. It's good to know the characteristics before you start graphing. Because the a is positive, we are in standard form, the a is positive, that is telling us that this is going to be an opening up parabola. Because there's a number here 2, it is 2 times the norm. That means it's going to be climbing 2 times as fast, which means we're going to have a very narrow parabola. We'll notice that there is no bx term. That means that this parabola is not going to shift left or right. It's going to stay centered in the middle on the y-axis. And therefore, if it's going to stay centered in the middle of the y-axis, we know the y-intercept, which is -8, is more than likely part of the vertex. Now, having guessed all this before, looking at characteristics, let's see if we can prove it. We know that the a equals 2. There is no b. And then again, the c equals -8, which we know this to be the y-intercept as well, the constant. Now, the formula for finding symmetry is take the opposite of d and divide it by 2a. Well, the opposite of 0 is 0, and 2 times 2 is 4, but 0 divided by 4 is still 0. So we know our axis of symmetry is at 0. So if we take that axis of symmetry and we put it down here in the center, so so far we're doing good. We said it was going to be centered on the y-axis. Let's see if our prediction is true about where the vertex is. So if x is 0, because the axis of symmetry is the same as the x-coordinate of the vertex, because that's where half and half is going to occur, right? That would be the lowest point for this. Let's take that and substitute it in. 2 times 0 squared minus 8. What does that equal for the y? Well, this works out to 0, and we can see 0 minus 8 is -8. So we would have been correct in assuming 0, -8, which would put us probably down here. Now, because we are solving quadratic equations, we can't just pick a point and just kind of randomly throw this up there. We've got to try and pick points that are going to kind of get us as close to the x-axis as possible. Well, we know that if we go one away from the graph itself, it is probably going to only go up 1, or in this case up 2, because it's 2 times. So that may only get us to -6. So let's try putting in 2 and see what that will happen. We plug in a 2, we get 2 times 2 squared minus 8 equals y. And 2 squared is 4, 4 times 2 is 8. And we see that 8 minus 8 is indeed 0, so that we know that 2, 0 is a solution to this. Now, because this point is 2 away from the parabola on the right side, the axis of symmetry, on the other side it will be 2 away to complete the parabola. If you want to know a better looking parabola, you could put in 1 to find out what that would happen to get you, just to prove that that's why we chose 2, because we could see it climb twice as fast. I'm going to guess it's going to be -6 before I get there, because again, I know it's going to climb twice as fast. So let's see, 2 times 1 squared minus 8 equals y. 1 squared is 1, 2 times 1 is 2. and 2 minus 8 is indeed negative 6. So there was that prediction I made that it was going to come in right here, 1 away on both sides. So we're going to graph that parabola. Boom. Like I said, I hope you guys graph better than I do. This freehand in the air isn't as easy as it looks. Okay, and because we're solving, we know that our solutions are ordered pairs. These are the solutions. So since these 2 points are the solutions, we need to record them. It could be negative 2, 0, or 2, 0. Those are our solutions to this particular quadratic function equation. Okay, let's take a look at another one here. Negative 12x plus 18 equals negative 2x squared. If we remember, it must be in standard form before we do anything else. So let's get it there. And the way we're going to do that is we're going to get the negative 2x squared off of the right side and get it onto the left side by adding 2x squared to both sides. What this does for me is put it in standard form. That way I'll have 2x squared minus 12x plus 18 equals 0. And we can see by having it in standard form that this again is going to climb twice as fast. That's what this 2 is telling us, and because it's positive, it's going to open upwards. This negative 12 here is telling us, because it's with the x, that this is somehow going to be moving side to side. It will not be centered on the y-axis. And the y-intercept is going to be at positive 18, so it's going to be very high up. We may not be able to graph that y-intercept, but at least we know kind of what we're looking at. If it's really that high, we're probably looking at something that is centered over on quadrant 1 somewhere. Well, let's see what's actually going to happen. So we know A is 2 and B is negative 12. So if we take the opposite of B and divide it by 2A, because that's for the axis of symmetry, that would mean positive 12 divided by 2 times 2, which is 12 divided by 4, which you know to be 3. So x equals 3. So what we're going to do is take and put on our axis of symmetry this 3 right here. That will be our axis of symmetry. Now that we have our axis of symmetry, we need to find our ordered pair of where our vertex is. So let's plug in 3 into this problem. So 2 times 3 squared minus 12 times 3 plus 18. What will that get us for y? Well, 3 times 3 is 9. 9 times 2 is 18. Minus 12 times 3, which is 36, plus 18 equals y. And as you can see where this is going, we're finding out that y equals 0. So our vertex then is at 3, 0. Well, if this opens up, we know that there's only one possible answer to this parabola, and that's right there where it's touching the x-axis at 3, 0. But we still need to graph it to prove our point, so we need to get one more point. So let's throw the number 2 into it and see what's going to happen. So 2 times 2 squared minus 12 times 3 plus 18. Let's find out what that equals. 2 times 2 is 4. 4 times 2 is 8. Minus 12 times, oops, I put a 3 in there. Good thing I caught that. That should be a 2. 12 times 2 is 24. Plus 18 equals y. 8 minus 24 is negative 16. Negative 16 plus 8 is 2. So we're going to cross at positive 2, positive 2. So positive 2, positive 2, which makes sense. It's going to climb twice as fast. And over here, we're going to put a point opposite and mirror it to the other side. And there's our parabola. And again, our prediction was pretty close. We said around the first quadrant, and there it is. And yeah, that'll probably cross at positive 18, way up on top there. Let's do one more. And here it says, let's find the roots. Well, if we remember, finding the roots of the equation is the same as solving the equation. So basically, I can set this equal to 0, and I can find the roots by graphing. Again, looking at it, this is a norm, what we call it, because it's 1x squared, what we normally expect. And because of this 4x, we know that it is going to shift left or right somehow. The A, which is positive 1, means it's going to open upwards. And we know that our y-intercept is positive 3. So right now I could put a dot on the positive 3 because I know the graph is going to go through there at some point. So let's find out what the axis of symmetry is. So A equals 1 and B equals 4. So the opposite of B divided by 2A would be negative 4 times divided by 2 times 1. Negative 4 divided by 2 happens to be negative 2, so we're going to put our axis of symmetry at negative 2. Okay, we know it's going to open up, so it's around here somewhere. we need to get our vertex before we pick a point. So we know that x is 2. Let's find out what the vertex is by plugging 2 in. So 2 squared plus 4 times 2 plus 3, that will give us our y. So 4 plus 8 plus 3. I think I did something wrong. Oop, it's negative 2. That's why I've got that there. I knew it. That would be too high. Okay, so negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. That looks a lot better. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So our coordinates of our vertex are at negative 2, negative 1. So if our vertex is going right here, we can kind of see where we're going to cross. We can mirror this point, but we need to know exactly where it's going to cross because those are the solutions. So we're going to have to put in the point 1 and see where that happens. Or I should say negative 1, because we want to locate where is it. Is this going to be 0? Hopefully it will be because it's a norm, 1 up, 1 over. It should be there, but let's double check by doing the math. Negative 1 squared plus 4 times negative 1 plus 3. Let's find out what that equals. 1 minus 4 plus 3. 1 minus 4 is negative 3. And our suspicions are true that that does equal 0. So we're at negative 1, 0. And then 1 away on the other side. So if we draw a parabola through those points, and we mark our solutions, there's one solution at negative 3, 0, and here's the other solution at negative 1, 0. So hopefully that helps you to look at solving quadratic equations by graphing. Not the most easiest method to do, but you can do it in a pinch if you've forgotten other methods to use.